All right, so I'm going to do an example here of how to find the distance between a point and a given line. And the shortest distance between any line and a single point is going to be a straight line, and it's going to be a perpendicular line. So we're going to use that knowledge to help us with this question. So step one is we're going to find the slope of the given line, y equals x plus 4. And this is in y equals mx plus b format, and we have to remember m is our slope. If there's no coefficient in front of x, m is 1. We just never write 1x. It's just implied. So our equation is y equals x plus 4. There isn't a coefficient there, but we know that it is a 1. So our slope of this line is 1. So in step two, we need to find a negative reciprocal of that slope in order to find the slope of our given or of our perpendicular line. And I'm going to just do this. We don't have to do this, but I always like to do this with whole numbers. If I have a whole number, I always put it into fractional form. So, for example, if we had a whole number of 2, it would be 2 over 1. In this case, we have 1 over 1. So now what we're going to do is we're going to flip this. Our denominator becomes our numerator becomes our denominator, and we change the sign. So since my original slope was positive, my negative reciprocal is going to be negative. And this, of course, is just going to work out to negative 1. So the slope of my perpendicular line will be negative 1. I'm going to use that in point P now, and I'm going to sub that into my line for equation for a line. So y equals mx plus b. I'm going to sub in my coordinate points from P and my slope of the perpendicular line and solve for b. So my point was 3, 5. And if I write my equation of a line of what I know so far about the perpendicular line, it's y equals negative 1x plus b. We could also just put y equals negative x plus b. So I'm going to sub my coordinate points in for x and y, and I know my slope, so the only thing I need to find is my y-intercept, which is b. So my equation becomes, instead of y, I have 5, equals negative 1 times, instead of x, I have 3. And those are my coordinate points, x, y. So 3 becomes the x, 5 becomes the y, plus b. Now I'm just going to simplify, collect my like terms, and solve for b. So minus 1 times 3, of course, is going to be minus 3. And when it goes to the left side, it's going to become positive 3. So now we have 5 plus 3 equals b. So b is 8. So now we have the information for this line of my perpendicular line. I can put it and rewrite it in the equation y equals negative x, because my slope is negative 1, plus 8, because that's our y-intercept, which we just found. So I'm almost there now. All I need to do is I'm going to use Desmos. I'm going to use the perpendicular line and the given line from the equation, and I'm going to find the point of intersection. So the given line was y equals x plus 4. The perpendicular line is y equals negative x plus 8. So now we're going to just go over to Desmos. And we have y equals x plus 4, y equals minus x plus 8. And right where the point of intersection is, we'll just see what that is. And it's 2 comma 6. So now I can use that. I'm going to come back here. So my point of intersection was 2, 6. I used Desmos to find that. So now I'm going to use my point P and my point of intersection, 2, 6, and I'm going to put that into the distance formula or length of a line segment formula and solve to find out what the distance is between the given line and point P. So My distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to use my POI as my x and y2 and my point P as x and y1. So 2 minus 3, and I should just put the coordinate points right up here so we've got them. So my point P is 3, 5. So 2 minus 3, so that goes in the brackets first, that's going to be squared, plus 6 minus 5. And once again, that's going to be squared. So in this one, we can now simplify our brackets. 2 minus 3 is going to give us minus 1. 6 minus 5 is also going to give us positive 1. And then I can square those. So minus 1 times minus 1 is going to be positive 1. And 1 times 1 is going to be positive 1. So my distance between the point P, which is 3, 5, and the line y equals x plus 4, in this case, is the square root of 2. Use those concepts and steps to see if you can help, if that helps to solve other problems given of this nature with distance. So see if that helps. If you're still confused, let me know, and I'll do a full write up for that actual question. Thanks for watching. Let me know if you have any questions.